Okay, it's on. Hello, everybody. Andrey and I came here from Berlin to tell you about the game that we created. Um, and in fact, what we want to do is encourage you and inspire you to also take on Elm and create a game of your own. It was a fun experience. So Elm is a functional programming language. And Zalando is a company. We maintain a website that allows people to buy fashion online. So another thing that we do at Zalando is we have something that they call a hack week. Hack week means for 1 week, everybody just drops what they usually do as a day job and implements things that they really feel need to be done all by themselves. So last hack week, Andrey came up to me and said, let's create a game in Elm. He was quite explicit that it had to be Elm that we use. And I thought maybe we can do something like something that's related to Zalando. So something about going to warehouses, picking up clothes and shipping it to the customers. That was my take on this thing. So what I usually do at Zalando is write Clojure and ClojureScript code. And I like to make illustrations as well, so I was a good fit for this. And Andrey has a background in Elm. So he had already written something like a Tetris game and put it on the, or it was featured on the Elm website. And so he knew what he was doing. And I had to learn it from scratch, but well, I was doing a Haskell class at the time, so it was right up my alley, really. Then at the Hack Week, you can just run around and advertise your game to, or advertise your project to other people. And so we took on other of our colleagues. So there was Wilcke, who was also new to Elm. And there was Arpad, who had a background in Lisp, and he had just, or he had, before he had implemented his own scheme called Mikamako. And so that's the team that we ended up with. In the background, you can see that we have this sketch that we did to the whiteboard to get clear all the mechanics of this game, how this should go down. So at Zalando, we have this slogan, put yourself into your customer's shoes. And for this game now, we had this idea, we could turn it around and make it, put our customers into our shoes for a change. So why really should we use Elm for this? Elm compiles to JavaScript, so it's used in web development quite a bit. And according to this survey by Brian Hicks, apparently it's also used a lot in games. And I think this is probably due to Elm being opinionated in the sense that it comes with something that they call the Elm architecture. And I think it lends itself quite well to games, but Andrey will go into the ins and outs and particularities of this a little bit later. So when we started out, I had to draw a lot of things first. And the other guys put in place the basic mechanics of how to render sprites and stuff to the screen. So we put a backdrop, we rendered sprites. This is what the programming part of this thing started out with. And I just had to draw a lot of sprites. I was helped by Wilcke, who gave me like he gave me this thing where all our delivery people were to be seen at the same time, and you could animate them. Maybe. So as you can see, I had to draw 24 of these to allow for this guy to move into all directions. Also, of course, customers. Yes, I had to draw quite a lot of customers. And they also had to start more or less naked because we didn't sell anything to them yet. And you may also notice maybe some familiar faces in the customers. To give this talk more relevance, we felt it would be appropriate to include some of the participants of this conference. So if one of these guys looks like you, that's on purpose. So, of course, also we needed to create a lot of clothes, yes. And we put those onto separate layers. So when you deliver the clothes to the people, you can mix and match. And yeah, so there is more variety in this thing. However, in our game, it's like this. If you fail to deliver the clothes to the customer quickly enough, they will become angry. And yeah, also needed to make a little bit of a change to the clothes because they have to animate with the angry customer. Yeah, so while I was doing all these drawings, the other guys weren't lazy. They were creating code. For instance, Arpad was working on the implementation of the A* algorithm, and Andrey had created this sandbox for him so he could focus entirely on the creation and implementation of this algorithm, and he didn't have to, think about how to render stuff. And then when the algorithm was just half-baked, we could click around and see how it reacted. And it was fun to see in the early stages where the delivery guy would take detours or run through obstacles and stuff like that, and then he would go back to the editor and make tweaks to improve it. Another thing that we didn't solve during our implementation week, because during this time we had all our items rendered statically into a certain place, but as an afterthought, we wanted to make this thing responsive. We wanted to make the game responsive to allow for rendering on different devices. And so we needed a way to randomly display these items. Yeah. So Andrey came up with a solution. You render the first item, and it gets placed randomly somewhere on the screen, and then the remaining areas get split into 4, and other subsequent items are placed, in the remaining space somewhere, and so on until all the space is filled up, or until your rules are satisfied of which elements exactly you want to have rendered. So it would be a stretch to tell you that we actually created this thing within a week. We worked night shifts and to make this happen. It was fun, but yeah, 1 week, okay, that's tough. And in fact, when we were presenting this, one of us would be presenting it to the rest of the company, and people would play it, while the other guys were still hacking away and implementing last-minute features. And so it came out that when you would, refresh the screen or refresh the browser, then the new features would have crop up when they were just implemented last minute. So probably you'll want to see it, yeah? So we have it here. Let's give it a demo run. So down there you see that's our delivery guy. And we need to go to the warehouse. Those are the square buildings. But first we need to check what do the customers really need. So there is a high demand for green shirts here. So Andrey, please go to the warehouse above there, and then you pick out maybe 2 shirts, so we can make this customer happy. Please just go back, and okay, give the person 2 shirts. Very nice. Also, you may have seen for a bit there, the guy had like a strike-through symbol. That means he doesn't want whatever he bought anymore. He wants to return it. This is something that occurs at Zalando as well from time to time. So Andrey, can you please go to the other warehouse now? Okay. And because I see there's a lady, she wants this shoe, this pink shoe. Please pick it up because it's already blinking. Blinking means she's getting nervous and she'll eventually be unhappy if she doesn't get it. So please give and deliver it. As you can see, this lady already looks a little bit pissed that she didn't get her green trousers. If you don't do anything for a while, people will get really, really unhappy. They'll start shouting. and then eventually they just disappear from the whole thing. And then you see those green customers up in the top. They're like all green now, but they will become red. And then when you lose 3 customers, that's it, game over. Also, another thing that I should mention is you cannot, uh, have as many items in your cart as you wish. There's only 4 slots, so you have to be careful and make careful planning. Like with a traveling salesman, you have to do this. Okay, so I guess you get it. Maybe we can just move on to the next slide now. So here you see an illustration of the Elm architecture. Just take it in, and I'll hand over to Andrey, who's gonna give you more of a technical, in-depth understanding of what this means.
Thank you, Kolja. So, who of you ever tried Elm before? Or, yeah, so plenty of people, actually. Well, others, please bear with me. There will be some Elm code in the following slides. So yeah, this is the Elm architecture. Let's make this a little bit more technical. So Elm architecture is a very simple concept. You have a model, you have a view that is the projection of that model. A view in Elm is the DOM, and DOM has also DOM events, and these events then they send messages. And update is a pure function that takes your message, it takes your old model, and it returns you a new model. And this is how the model is reduced over the update function, and this is how the whole thing is running. So it's slightly more complex than that. You also have subscriptions. That is also a pure function that takes the model and returns a list of subscriptions. So you can hook into some global events like window dimensions, animation frames, time intervals, and mouse, keyboard, and so on. And update function can also return commands. So commands is a side effect kind of thing, but it's a side effect is a data. So it's like just an instruction that you can use to ask Elm, please do something, and once it's done, please come back and send message back to me. So both subscriptions and commands, they also produce messages just like the one that you get from the view, and all these messages are then sent into your central update function. So in Elm, it is important to mention that Elm is not just a language, it's also a framework. And what you can get from the HTML app program is a function that you can run, and you just pass in your hooks, and then it will just work. So what you have to implement is the initial model and initial command. You have to implement update function that takes your custom message and the model and returns model and command. You have to implement subscriptions, and you have to implement view. And then what you could use is just this HTML app program, and it takes a record where you just fill in the attributes, and then it will just work. So, and in the following slides, I will go deeper into model, update, and view, and we'll talk a little bit how we use them in our game. So a little bit about the model. So model, it's very important to get the data structures correctly in the functional mutable world, because the way you structure your data has a lot of effect of how you write your functions. So you have to really optimize the data in order to not write a lot of code when you deal with that data. So we have this example, and in the traditional object-oriented approach, how would we have structured articles? So it would look like this. We would have a house, warehouse, and delivery person as just objects that would have a list of articles. So house will have list of articles that are delivered to that house and a list of articles that are waiting to be returned. So list of articles for the warehouse and for the delivery person. And the functionality that we would need to implement is picking up an article and spawning a new request. So picking up an article would require us to mutate a lot of things. So we would have to update the list of articles inside the warehouse, and this will create a new warehouse object that is in all the objects of the game. And the same with the delivery person. When you have to add this article into the inventory of the delivery person, you would have to mutate the delivery person. Also spawning new requests, like the new order from the customer, will, customers cannot order articles that are not there in the game, so you would have to traverse all the data, and you will have to find what are the articles in the game, and this will also require some code to write. And what we went with was having one simple list of articles, and we tagged them with location. And for this, we used union type state. So an article can be in stock at warehouse, waiting return from house, delivered to house, or picked. So it actually allows us uh, to write less code in order to explain this functionality. So picking up an article would be as easy as just changing the state from in stock at warehouse to picked, and spawning a new request is just like to get the list of available articles. We would just have to filter through the list of articles and find the ones that are not awaiting return, or not delivered to house. But sometimes it's not easy to get the data right. So sometimes you just have to implement something quickly, and Elm has a lot of benefits regarding this. So Elm compiler can help you in further refactoring of the code, because the language is strongly typed, and the compiler will guide you through your shotgun surgery that you apply to the code. So here is a small example, small refactoring example. So before we had separate lists of map objects in the model, so we stored them in separate lists, and all the objects, warehouse, house, and obstacles, they were of different types, so different record types. But what they had in common was position and size. And we needed them to be in one list, because we wanted to use them in the pathfinding algorithm, and we wanted to use them in the random algorithm. So if so before we had to convert them into a single type and then convert them back to put them into the slots in the model. But what we did, we unified the type, the map object type, and we used union type in order to explain what are the different attributes of these objects. So we have created a house category that takes capacity of the house. Same with warehouse, and the fountain category stored the animation state of the fountain. And the tree category, tree, yeah, just a tree. And this change alone, including the random generation algorithm, actually cost in removing more lines of code than adding code. So this is the case in Elm. Whenever you want to introduce some new abstractions, whenever you want to pull some data structures together, you end up adding features by removing code. And yeah, this is, I think, it's very nice about it. Also, another feature, like the Elm compiler guides you through, so you spend less time playing the game, you spend more time programming it. So the next thing is the update functionality, the actual reducer of the model, and for this I would like to talk a little bit how we did animations in the game. So there is this nice module called animation frame, and this gives you a subscription to the animation request animation frame API in the browser. So with just simple code like this, you could subscribe to animation frame.divs. So here we create our custom message type that is tick of time. So time is in the payload of the message. And animation frame.divs gives you a subscription to time differences between frames. And you tag them with the tick constructor, so this will give you the subscription to your message type. And then in the update function, we use the pattern matching case operator to extract the elapsed time from the payload. And then we call our animation loop function. We pass it the time since the last frame and the previous model, and this will return you the model after this animation step. And here is the simple implementation of the animation loop. Here we store the frame, the current frame, and the timeout. So we increment the timeout, we add elapsed time to the timeout, and whenever it reaches 1 second, we increment the frame and we reset the timeout. Otherwise, we just store the accumulated value. So let's run it. So here you see that the timeout, once it reaches 1 second, the frame is incremented. Oh, and by the way, haven't I told you that the presentation itself is the Elm code? So this is the actual Elm program running. Another important thing is you have a lot of different objects in the game, and all of them, they have to be animated. So how do we compose animations? This is a very simple example excerpt from our game. So here we have two separate modules, one for delivery person, another one for customer. And in order to animate them, we take this attribute from the record and we apply this animate function to that attribute, so it gives you the animated value. So for customers, it's a little bit different because customers is the list of customers. So what we are doing there, we partially apply animate function with the elapsed time, and this will give us a function that takes old customer and returns the new animated customer. And then we map this over the list of customers from the model. And this will produce a list of animated customers. The last part is the view. So initially we rendered our game using Elm HTML module that has a similar implementation to React, if you have heard of it. So it uses a virtual DOM concept. You describe your view declaratively, and then the runtime will create a diff between the previous description and the new one, and will only apply patch to the actual DOM in the browser. So this is very efficient, and it causes less amount of reflows in the browser, but we noticed that the performance was not good for us, especially on mobile devices. So we tried to explore what were the other options, and one of them was the canvas implemented in the graphics module. However, that one didn't have a way to work with texture offsets, so we needed a way to store animation frames on one single sprite, so this was not possible. So we used WebGL instead. And Elm WebGL is also very uh, nice and straightforward approach. So it's much easier than using WebGL from the JavaScript, because then you would have to compile the program, link all the stuff together. And in Elm WebGL, you just declaratively uh, describe all the renderables, and then yeah, it will work. So of course you would have to learn shaders, but Elm has also some nice features. So it does automatically generates type signature for your shader. So so a little bit about the transition. So when we used Elm HTML, what we did, we rendered in the view function. We uh, rendered each object into the list of our own custom boxes that had some information about what is the sprite that has to be used, what is the position and dimensions of the object, what's its layer, and so on. And some of the boxes, they had also on-click events. So, and then these boxes, they were rendered as just a bunch of divs in the browser, and we used z-index to z-index CSS property to implement layers. And we used the browser feature. We just had on-click events on those divs. So, however, as I said earlier, this caused a lot of like performance penalties on mobile devices, because we had like a lot of moving elements, a lot of moving divs inside one container, and this was causing like slow diff and slow updates of the real DOM. This thing could have been solved with the key attribute, where you could say that please don't touch this element, or like you could actually have the exact one-to-one mapping of elements. However, this didn't fit well into our code, and so would have to rewrite a lot anyway. So we chose to go with WebGL solution. And the difficulty that was there is we couldn't use on-click events. We had to manually implement our own detection of what object in the game was clicked. And for this, we created a special union type. The box was a union type. It could be either a textured box or a clickable box. And then we did some pre-rendering in the update function that would create us two lists of boxes, one textured boxes and another list for clickable boxes. So on the on-click event, we would have manually calculate which box was clicked and then dispatch the message from that box. And then in the view function, we simply used the textured boxes and we sent them to WebGL for rendering. So yeah, this is the timeline from Chrome debugger. You probably saw it in the keynote. I spent a lot of time looking into this. So here what you can see, that the game runs pretty fast. So all the frames that you see there, milliseconds, it's almost 60 FPS. But what's wrong is there is this red line on top. This means that there is layout thrashing happening in the browser, so it does some unnecessary recalculations of the layout. And also the heap size is pretty large, so it's almost 20 megabytes. And I tried to improve that, and in the end we have like everything is green there on top, and heap size has decreased. And also we reduced the scripting time. So before we were doing like a lot of recalculations, a lot of high computations in the animate function that was running very frequent. And what we did, we extracted them into time interval subscriptions. So we ran those high time-consuming computations less frequently than the request animation frame happened. So we are still working on the game. Just recently, Kolja drew the boxes of the delivery person, so you could see like those jumping boxes depending on how many are there in the inventory. Uh, our plans are to go live on the actual 4.4 page of Zalando website, and we would like to add sound effects, improve the performance and the gameplay. We are of course looking for contributors, so it's there on GitHub. Please check it out. Um, and the last thing that I would like to mention, so whenever somebody asks me about Elm and I explain all the nice features of the language, how welcoming it is and how good is the experience working with compiler, but there is one question that people ask me, like, but do you use it in production? And and this is a tricky question that I couldn't answer before, but today we are going to change this. So today we are going to put it live. So we will have Elm in production, and I hope that my colleagues enabled the feature. So so now I think you can access it on the actual 4.4 page of Zalando. Thank you. Questions? Of course, yes, I would like to use Elm for the new project. Uh, there are some ways of actually introducing Elm into your code base, and even has just recently open sourced the module that allows to integrate Elm into your React.js application as React component. And the JavaScript interop is pretty simple, so you could use ports, so it's like a pub/sub way to communicate. So yeah, I think go for it. So, but yeah, first you can try it on some small project, maybe some internal tool. Um, yeah. Uh, we are going to push it on to GitHub, and we will send the link with the. I hope that the conference will retweet the link.
Can you mention the engine thing?
So it's powered by the Elm slideshow. That is the presentation engine that I implemented in Elm when I was like writing the introduction to Elm. When I was creating an introduction to Elm presentation, I thought it would make sense to use Elm for that. Because like I'm a front-end developer, so I would use something HTML5 presentation engine, but using JavaScript to present Elm like felt unnatural to me, so I created my own presentation engine. Uh, so to integrate it with the server side, there is the HTTP Elm HTTP package that allows you to consume APIs. So you get the JSON and the payload, and then you use decoders to decode them into your typed object, into your typed structures. Uh, so so speaking, like the performance was slow because I think that the virtual DOM is actually, it works better when you have like trees of objects, so it could easily go and see what's changed. Uh, but what we had just a bunch of diffs in one single container, and whenever like one diff is removed, all the rest of them are reflowed and recalculated. That's why. Uh, of course, yes. So as I said, we also reduced the scripting time inside the animation frame. And the way we did it, so the request animation frame is executed frequently, and there was some computations that, like some cleanups, like removing some dead objects that are not linked. This thing has been moved to less frequent interval subscription. So it occurred every second or so. So we didn't have to run it every time. But also because with WebGL, you can just send stuff to it without taking care about the diffs. So it doesn't need to diff anything. So you just render every time. So personally, I just use Atom, and Atom has Elm make integration. So whenever you change something, it will automatically highlight what's wrong, like that the type signature doesn't match and so on. So under the hood, it just runs Elm make command and gets the nice error message and shows it like at the exact line of code that you changed. Um, and for the teamwork, we just used GitHub.
We also have CI by Vignette.
So our colleague Vinyesh implemented CI solution, so we used Travis to try to compile the master branch and publish it to GitHub pages. So whenever something is merged into master, if Elm compile succeeds, it's there pushed automatically to GitHub pages, so we didn't have to take care of that. So we always had the most recent version that compiles working, and yeah.
So I have some experience with Haskell and not with Elm. How would you compare the experience of using Haskell with
Um,
Elm?
so my Haskell knowledge is very small. What I know, basically some stories from some Haskell developers who come into Elm and they want some new features that Haskell has but Elm doesn't, like type classes, for example. I think this is the most thing that people request from Elm, and Elm is driven by very pragmatical things. So uh, they don't introduce new features into the language just because it's a feature that someone used. So Elm is more towards solving actual problems of the UI development. So and a lot of people who are using Elm were people who were doing their own front-end development using JavaScript, and then they converted into Elm. So adding some new abstract, like new complicated features from Haskell would make the language not as friendly to the newcomers from this side. So I guess that's why it's not there. But like if you want type classes, then I think you could go with pure script, for example, that has now.
Do you experience any problems with garbage collection follows time or something? Because Elm obviously produces a lot more objects than like typical JavaScript program. So
Uh,
how smooth
no, I haven't seen this in the timeline. There was no problems with this so far. I think that JavaScript engines nowadays are pretty powerful to deal with this, because a lot of other libraries like React. There is immutable JS library by Facebook and there are some other immutable libraries that are quite popular nowadays in the JavaScript world, and people have no problems with this. So I heard from one friend who told me that it was a problem back in the days when we had uh, low memory devices, like some phones that had not a lot of memories, and this may just crash the browser there. But nowadays, I don't think that's an important concern. Thank you.